Hello everyone, this is Miss Tim's lesson on grade 8 math. This is the second video on factoring polynomials. So ready your notes, ready your pens as we go through learning factoring polynomials. Now before anything else, I would like to remind you that there are some instances that I would be asking questions. If that comes, I would like you to pause the video, think over of what could be the answer, then unpause if you're ready to proceed. Previously, we tackled about factoring by Greatest Common Monomial Factor, abbreviated as GCMF. But before, we were focusing on prime factorization. In this video, we will be using law of exponents. Are you ready? So let's recall first the law of exponents. Let's try this. What is the product of a to the power of 4 and a to the power of 6? We are given two choices. Which do you think between these two is the correct answer? Pause. Do you have the answer now? Correct. It's a to the power of 10. Now why do you think so? Now this case belongs to product rule. In product rule, you are given two factors that has the same basis. A to the power of 4 and a to the power of 6. The base is a. So we simply copy a, then we add the exponents 4 and 6. So the answer is a to the power of 10. So again, what do we do if we have product rule? We simply copy the base and add the exponents. Another one. What is the quotient of a to the power of 12 and a to the power of 3? You are given here two choices. Which do you think between these two is correct? Pause. Do you have the answer now? Correct. It's a to the power of 9. Now, why do you think so? This case belongs to quotient rule. In quotient rule, the same in product rule, the bases should be the same. A to the power of 12 divided by a to the power of 3. The base is a. So we simply copy a, then the exponent 12 in the numerator and exponent 3 in the denominator. We simply subtract the two. So it becomes a to the power of 12 minus 3 is a to the power of 9. So what do we do if we encounter quotient rule? We simply copy the base and subtract the exponents. Let's have another one. What is the quotient of a to the power of 4 and a to the power of 3? Oh, this is a quotient rule, and we have three choices to choose from. Which do you think is the answer? Pause. Do you have the answer now? Yes, it's a. Now why do you think so? As I told you, this is a quotient rule. A to the power of 4 divided by a to the power of 3. What should we do again? Yes, copy the base, then subtract the exponents. 4 minus 3. So that is a to the power of 1. But why it's not 1? Because a to the power of 1 is simply a. There is no need to write 1 as an exponent. Remember that 1 as an exponent may not be written at all. Lastly, what is the quotient of a cubed and a cubed? Another quotient rule. We have here three choices to choose from. Which do you think is the correct answer? Pause. Do you have the answer now? Yes, it's 1. Why do you think so? Again, this is another case of quotient rule. A cubed divided by a cubed. Simply copy the base, then subtract 3 and 3. 3 minus 3 is 0. But why it's not 0? Because any variable or any number, aside from 0 of course, exponented by 0 is 1. Again, any value other than 0 powered by 0 is 1. Are you refreshed now on laws of exponents? Let's proceed. Using the factors of 24 and 30, what is the greatest common factor? 24 has factors of 1, 2, 3, 4, 6, 8, 12, and 24. While 30, we have 1, 2, 3, 5, 6, 10, 15, and 30. 1, 2, 3, as well as 6 are common factors. But which among these four is the greatest? It's 6. The greatest common factor is 6. So how do we factor polynomials? We have to follow these steps. It is very important to check first common factors of the coefficients and or common variables on each term of the given polynomial. If we can see common factors, then we can use Greatest Common Monomial Factor or GCMF. Second, we factor out the common monomial factor. In using laws of exponents, we simply copy the common variables with the least exponent. Then divide the given original polynomial with the GCMF. And then lastly, write the factored form, which consists of two factors, the GCMF and the quotient. This time, we will be using the same examples that we had when we discussed GCMF using prime factorization. This is for us to easily differentiate which method the easiest for us to use. So let's factor AB plus AC. As you notice, the first term AB and the second term AC has common variable, and that is A. Therefore, we can say that A is the GCMF. And then let's prepare the parentheses in which we can enclose the quotient. Now, in getting the quotient, we divide AB with the GCMF, which is A. A divided by A is 1. So we can simply cancel out A. Therefore, the answer is B. Copy the sign plus, then AC divided by A. Again, A divided by A is 1. So we can cancel out A. And the answer is C. So the quotient is B plus C. So the factored form is A times the quantity of B plus C. So let's factor 6mn plus 3m. The first term, 6mn, and the second term, 3m, has common factors. 6 and 3 are the coefficients with common factors. The greatest common factor is 3. And the variable m is common in the first term and the second term. So our GCMF is 3m. And then we enclose inside the parentheses the quotient. We divide 6mn with the GCMF 3m. 6 divided by 3 is 2. M divided by m is 1. There is nothing to divide n, so remain n. So the quotient in the first term is 2n. Copy the sign plus. Then the second term, 3m, divide by the GCMF 3m. 3 divided by 3 is 1. M divided by m is still 1. 1 times 1 is 1. So the quotient is 1. Therefore, the factored form is 3m times the quantity of 2n plus 1. So let's factor 6p squared q cubed minus 8p cubed q squared r. 6 and 8 are the coefficients, and they have common factors. The greatest common factor is 2. The common variables are p and q. The least exponent of p is 2. The least exponent of q is 2. Then, we enclose inside the parenthesis the quotient. We divide 6p squared q cubed with 2p squared q squared. 6 divided by 2 is 3. P squared divided by p squared, 2 minus 2 is 0, and p to the power of 0 is simply 1. Q cubed divided by q squared, 3 minus 2 is 1, and q to the power of 1 is q. So therefore, the answer is 3q. Then copy the sign minus. Then divide 8p cubed q squared r with 2p squared q squared. 8 divided by 2 is 4. P cubed divided by p squared, 3 minus 2 is 1, so this is p. Q squared divided by q squared, that's q to the power of 0, or simply 1, remain r. So the answer is 4 times p times r. And that is our factored form. Let's factor 12x squared y cubed minus 15x cubed y squared z plus 18x y z squared. Now the first, second, and the third term has common factors. 12, 15, and 18 has the greatest common factor of 3. And x is repeated, y is also repeated. Z is not repeated in the first term, therefore z is not a common factor. The least exponent of x is 1, the least exponent of y is also 1. And there is no need to write 1 as the exponent. So let's have the parenthesis for the quotient. So let's divide 12x squared y cubed with the GCMF 3xy. 12 divided by 3 is 4. 3 divided by 3 is 1. X squared divided by x is x. That's 2 minus 1. So x to the power of 1 is x. This one is 1. Y cubed divided by y is y squared. And this is 1. So the quotient is 4xy squared. Then copy the sign minus. So next let's have 15x cubed y squared z divided by 3xy. 15 divided by 3 is 5. This is 1. X cubed divided by x is x squared. 1. Y squared divided by y is y to the power of 1, or simply y. This is 1. And there is nothing to divide z, so remain z. So the quotient is 5x squared y z. Copy the sign plus, then 18xy z squared divided by 3xy. 18 divided by 3, that is 6. X divided by x is 1. Y divided by y is 1. There is nothing to divide z squared, so remain z squared. Therefore, the quotient is 6z squared. And the factored form is 3xy times the quantity of 4xy squared minus 5x squared yz plus 6z squared. And that's it. Did you understand what we have discussed? Let's apply what you have learned. What is the GCMF of the given polynomial? Ru to the power of 4 plus Ru m cubed e. This time, there are no choices. I would like you to answer it on your own. Pause. Do you have the answer? Yes. It's Ru cubed times the quantity of u plus m cubed e. Another one. What is the factored form of the given polynomial? A to the power of 7 r squared m cubed ys minus 8rm squared ey. There are no choices. Try it on your own. Pause. Do you have the answer now? Yes. The answer is ARMY times the quantity of a to the power of 6 RM squared S minus ME. Lastly, what is the factored form of the given polynomial? A b to the power of 8 ts to the power of 10 plus bt to the power of 3 s to the power of 9. I want you to do it on your own. Pause. Do you have the answer? Yes, it's bts to the power of 7 times the quantity of ab to the power of 7 s cubed plus t squared s squared. Very good! Remember, before using any other methods of factoring, check first if there are any common factors and use GCMF. In using GCMF, you can choose which method would you prefer. Is it prime factorization or is it the laws of exponents? Thank you so much for going through with me learning factoring polynomials. Did you take notes? Did you understand? Do you have any confusions? If there are, or any suggestions, you type it on the comments. Until next time!